Chapter 2, Pin Tumblers, identifying them, how they work, plus the tools and skills you will need to defeat them. Pin tumblers can be found in many places, most commonly on house deadbolts, doorknobs, cabinets, padlocks, etc. They usually have pins visible in the keyway. These pins are often round and somewhat pointed at the end. The pins are spring-loaded and will spring back down when you push up on them. This is a plug. It is the part of the lock that the key turns. The hole that the key enters is called the keyway. The little protrusion in the keyway is called the side ward. These wards fit into the grooves along the side of the key so only the proper type of key can enter. And this outer cylinder is called the hull or casing. This half remains in place and does not rotate. Inside you can see the pin columns. Although many pin tumblers have 5 pin stacks, the number may vary depending on the quality of the lock. Every pin column consists of 1 spring and 2 pins. The top pins are usually the same size and touch the springs and the bottom pins. The bottom pins vary in size to complement the shape of the key. They touch the top pins and rest on the keyway ward. The pins are pushed down by the springs. The ward prevents them from hitting the bottom of the keyway, from falling out, and also allows the key to slide under them. Before any key is inserted into the lock, the springs will push the top pins down. These pins will extend past the hull and into the plug. As these pins protrude into the holes in the plug, they will hold the plug in place and prevent it from rotating. The bottom pins can also stop the plug from turning if pushed up too far. As long as there is a pin that crosses the dividing line between the hull and the plug, the cylinder will be locked. When the correct key is inserted into the lock, the blade of the key raises the pins. The bottom pins will rest on the notches of the key. When the key notch is at the correct height, the separation between the top pin and the bottom pin will be at the same height as the separation of the hull and the plug. When this occurs at every pin column for the correct key, there are no pins blocking the shear line. There is now nothing to prevent the plug from rotating. The key can now turn and unlock the pin tumbler. There are standard sets of tools that many locksmiths and security professionals use. By no means are you limited to just these professional tools. You can find many common objects that will work just as well for you, if not better. The hook pick is the standard tool for lockpicking. With these hook picks, you can feel each individual pin and lift them without disturbing its neighbors, or you can rake across all the pins. The half diamond picks are easy to insert, remove, and rake over the pins. Use one of the appropriate size and shape so you can manipulate individual pins if needed or easily rake over many pins if desired. The ball picks are very smooth for raking across pins and are especially useful for dealing with flat wafers. The double-sided picks are useful for double-sided locks, such as the double-sided wafer lock. We'll talk more about those later. Rakes of different shapes and sizes are often useful. Different tools work better for different locks. Lots of random household objects can be used. Use your imagination. The torque wrench is one of the most important tools. It is used not only to turn the plug, but also it is used to help you feel what is going on inside the lock. The smaller end is inserted into the keyhole, and you use the longer end to rotate the plug. Make sure you leave enough room in the keyway to insert your second tool. Keep in mind, even if you watch this movie and fully understand all of the concepts, you will still not necessarily be good at picking locks. There is no substitute for practice. Get yourself a variety of locks on which to practice. In order to successfully pick the pin tumbler lock, all you really need is a torque wrench and a hook pick. There are many methods you can use. We'll cover a few, plus some automatic tools. The torque wrench is inserted into the keyway and used to rotate the plug. Apply a continuous light turning pressure. The pick is used to manipulate the pins. Keep a slight turning pressure with your wrench while doing this. Raking is one of the easiest methods to learn, although it can be difficult to fully master. To rake successfully, you need to have just the right touch. This is something that can only be learned through practice. Raking is one of the fastest hand methods when it works. First, place a torque wrench in the keyway, leaving plenty of room to access the pins. Now, apply a gentle amount of turning force in the correct direction. It is very important to apply the appropriate amount of force. Usually beginners tend to push too hard. Often just a light touch is needed. The idea is to simply take a raking pick and repetitively pull it across all the pins in such a fashion as to push the pins upward and unlock the pin tumbler. Make sure you apply a continuous gentle force to all of the pins as you rake them. Don't skip any. While this may sound too simple at first, it can work well if done properly. Your first pass will most likely not be successful. You must make many passes. With each pass of the pick, slightly increase the turning force on the torque wrench. As frustration sets in, people have a tendency to apply too much force. This won't work and only leads to more frustration. Different rakes and styles of raking work better for different styles of locks. Experience and practice will show you which ones work best. Some require quick, light movements, while others take slow, stronger passes. Remember to use a variety of practice locks to get comfortable with various techniques. Another method you can use is to set each pin individually. You have to understand more about the inner workings of the lock, but the knowledge will help you greatly. As always, your goal is to clear the shear line of any obstructing pins so the plug may rotate. If locks were perfectly manufactured, it would be impossible to pick individual pins. But in the real world, locks have many imperfections and are built to affordable tolerances. The better the tolerances, the better the lock, the more it will cost. Metal pieces have to slide and rotate by each other, so there must be small gaps to make this motion possible. The first aspect we are going to look at is called binding. This occurs when the plug tries to rotate and crimps a pin against the hull, holding it in place. When this happens, you will no longer be able to rotate the plug, since the pin is being held in the way. The holes drilled in real locks will not line up in an exact line. Because of this, when you rotate the plug, one of the pins will bind first, while the others are left loose. Since each lock is different, each lock's pins will bind in a different order. If you rotate the plug in the other direction, the pins will bind in the opposite order. First, use your pick to determine which pin is binding the most. Then, push up on that pin until the top pin is completely inside the hull. The top pin that used to be crimped between the hull and the plug is now no longer in the way. So the plug will rotate slightly until it crimps another pin stack. You should be able to hear or feel this slight movement with your torque wrench. The top pin is now trapped and will rest on the top of the plug while the bottom pin is free to fall downward. This is called setting the pin. You are now ready to move on to the next pin column that is now binding. When you are pushing up on the pins, be careful to stop at just the right point when they set. If you push too far, the bottom pin will continue and move into the hull as well. The plug and hull will now bind the bottom pin, which will keep you from rotating the plug. You can tell if this happens when you remove your pick and the bottom pin neither springs down nor free falls down. Simply reduce the pressure on your torque wrench until the pin falls down. Several other pins you had previously set may also fall when doing this, so be careful. You can also try picking the pins in a different order to make things easier. Now it's your turn to start picking pin tumblers. First, insert a torque wrench into the keyway. Apply a gentle turning pressure with the turning tool. Again, the word gentle is emphasized. If too many pins bind, they will jam too tightly. If the pins that do bind are too difficult to push up, then you are turning too hard. When you become frustrated and tired, you will likely start turning harder. When this happens, take a break and recover. Well-machined locks and those made to tighter tolerances will require the use of more torque. Padlocks and some doorknobs also have to turn a spring-loaded locking bolt, so these require more torque. Experience will tell you how much torque to apply. When you pick padlocks, there is the additional skill of holding the lock in the same hand that you use to turn the wrench. With practice, you will learn which method suits you best. Try a variety of methods. Remember, this isn't always an exact science. While you are applying this gentle turning pressure, use the pick to feel the pins. Don't use your sight, just feel them. By knowing how they respond in various situations, you can create an internal map in your mind of what the lock looks like and the state of all the pins. Remember to visualize. This is a critical skill to learn. Just as many athletes try to visualize before a game what they will have to perform, so should you visualize yourself how you will pick the lock. Next, attempt to determine which pin is binding the most. Then, position your pick directly under it and use the tip of your pick to make contact with the bottom of the pin. Apply a small amount of force, pushing the pin upward in your attempt to push the top pin completely into the upper chamber of the lock. Be certain not to disturb the neighboring pins too much during this process. There are a variety of hook pick sizes that are better for different shaped locks. Also, you can use any other type of pick or rake that works well for you. Remember, the only rule is to use what works. When the top pin completely clears the shear line and enters the hull, you will have set the pin. This is also called breaking the pin. When this happens, you will hear or feel a small click. When your senses are in tune with this, it will become an earth-shattering event. You will feel the pin respond differently. At first, you had to fight against both the top pin binding and the spring pushing down. For a brief moment, in the gap, there will be just the spring resisting you. Then there will be a large resistance as the bottom pin hits the edge of the hole in the hull. You must get used to how this feels. You will also feel the click in the hand that is holding the torque wrench. The wrench will give and the plug will rotate ever so slightly and then stop. Although you can feel this, you probably won't be able to see it. Treat the tools as extensions of your body. Don't trust your eyes. Use your other senses to experience the lock. After you have set the pin, lower your pick and make sure that the bottom pin falls down freely. If it stays up, then you have pushed the pin up too far. You can either relieve some tension from the wrench in order to let it drop or start over. If the spring pushes the pin down, then you haven't set it yet. Perhaps this pin isn't the one binding the most, or you didn't push up far enough, or you didn't apply enough torque to the wrench. When the last pin is set, the shear line will be clear with no obstructions, and the plug will be free to rotate. The lock is now open. The actual mechanics behind each lock that unlocks, freezes, or opens vary greatly. Padlocks usually have to actuate a spring-loaded locking bolt in order to release the shackle. This means that you will need to apply a little more torque to get them to open. Shimming is another method of bypassing a lock. The idea is to insert some sort of object into the locking mechanism and move the locking bolt, or whatever is holding the shackle inside the lock, out of the way. Since the mechanisms vary greatly, there is no standard method for shimming a lock. Shimming can also be effective on a wide variety of padlocks. Padlocks usually work by having a spring-loaded locking bolt fit into a notch in the shackle in order to hold it inside the lock. Often the locking bolt will have an angled top, which allows the shackle to be closed without unlocking the lock. This means that the locking bolt must be spring-loaded. So, if you can fit a very thin, strong object into the lock parallel to the shackle, you can sometimes slide the locking bolt out of the way and spring the shackle open. This requires that the lock's hole for the shackle is large enough to also allow for the shimming tool to fit inside. This method will also work for warded padlocks. The actual lock type is almost irrelevant. Padlock shims are often sold that are specifically made to help you deal with padlocks with less hassle. They are made of thin yet strong material that can be inserted into the padlock and then rotated to release the latch. They are often tapered to make them much easier with which to work. Shimming is also very effective on common doorknobs. The latch is the portion of the locking bolt mechanism that sticks out of the door into the door jamb and holds the door shut. One side of the latch is angled so that the door can be closed without turning the handle. This is because it is spring-loaded. All you need to do is to take a tool and stick it in the gap between the door jamb and the door. You may have heard about credit cards being used for this. Try not to break your card if you attempt to use it for this purpose. Most latches will have springs that are too strong and will require a stronger, different shaped, or better tool for this purpose. Make contact with the bolt and work it back into the door, and the door will open. Some door jambs are better than others at blocking access to the door's latch. Many sophisticated doorknob assemblies used in commercial applications are not susceptible to this. They have additional protrusions that stick out of the door. This anti-pick latch is pushed into the door when the door is closed. The mechanism then mechanically prevents the main latch from being pushed back into the door without opening the lock. Sometimes you don't have to pick the lock at all in order to open it. You can merely bypass it. This is called bypass picking. It requires that the lock allows for it. Therefore, this method only works on lighter security locks that have an exposed locking bolt in the rear of the keyway or elsewhere. Many desks, cabinets, and a few padlocks are like this. The concept is simple. Insert your bypass pick all the way into the lock and ignore the pins or wafers completely. Attempt to move the locking bolt manually with your tool. Whatever the lock would have done if unlocked, you should try to do the same thing to the bolt. You may be able to move it out of the shackle or slot and allow the lock to open. It is a simple concept when you are lucky enough to have a lock that allows this. When done properly, impact picking and vibration picking can be one of the fastest ways to open a lock. These methods are also beneficial because they require less skill. These methods work on most pin tumblers. Law enforcement officers or other professionals who must open locks in emergencies when time is critical will use this method. They may often have other issues to worry about and do not have the time or inclination to learn the more subtle aspects of the art of lockpicking. You can generally pick up the right tool and use it effectively after some experimentation. Experience is still very important for you to have the right touch. These tools do require, though, a lock that is susceptible to these methods. You will need to have an appropriate pick gun. This is a tool you hold in one hand that usually has a lever or trigger that you squeeze with your fingers to provide a vibrating or snapping action. Remember that you still need to use a torque wrench with these devices. Place the pick gun all the way into the keyway. Insert the torque wrench, applying a rotating pressure on the wrench, and squeeze the trigger. Do not move the gun vertically or laterally while picking. As the pick strikes the pins and knocks them upward, use your torque wrench to cause the plug to catch the top pins as they jump into the hole casing. This method uses a snapping motion. A flat tool accelerates toward the pins and strikes them all simultaneously. The physics is similar to billiard balls or those desk toys that have one marble swing and hit a second. The momentum from the first ball is completely absorbed and passed to the second, which moves on roughly with the same speed, leaving the first ball in place. This is what the impact attempts to do. It impacts the tips of the bottom pins with just enough force to knock them into the top pins, thus knocking the top pins up into the hull. The lower pins themselves hopefully stay down, because they imparted all of their energy into the top pins. You really don't have to know all of this theory to effectively use a vibration or impact tool. Just put it in the keyway, pull the trigger, and rotate your torque wrench at just the right time. You must be sure to make contact with each of the pins. When using an impact tool, make certain that you impact the center of each of the pins exactly straight on and at the same time. This means the blade must be exactly parallel to the keyway. Some tools have angled blades to allow holding the tool at an angle if space is tight. These will require a bit more practice to ensure that the blade is always parallel and strikes all pins simultaneously. Different locks will require a different amount of force for their pins to bounce properly. The locks must also be in good working order. If the lock is dirty, the pins may be unable to bounce freely inside their chambers.